GitHub under John Stacks, and I actually just joined Twitter last night. Yes. So under Stacks_overflow. So I kind of want to tell you guys today about how we moved to a multi-cloud architecture, kind of what that entailed, not just for our engineering and DevOps team, but also for our business. But before I do that, how about a quick round of applause for all of our sponsors for helping make this possible? And then also, can I get any of the organizers to stand up? Yeah, how about a round of applause for them? They took probably months preparing for what's going to be a 2-day conference. We've got a great venue and a lot of great talks, so I'm excited to hear the rest of them. So, real quick, I want to tell you guys a little bit about what C2FO is. I want to kind of set the background for what our business does and how we support our business. So currently, the problem is that there's inefficiencies in the financial system. It takes businesses too long to get paid, approximately 60 days on average. Furthermore, banks loan at a high interest rate and offer a low interest rate. So if you think about when you go to put your money in a bank, you get a low interest rate, but yet your mortgage might be a lot higher rate. And money is locked up in accounts payable. So the solution to this is, we said, what if buyers pay suppliers early at a discounted rate? Well, the suppliers will get the working capital that they need at a lower cost than borrowing, and buyers get an effective discount on the invoices at no risk because they were going to pay the suppliers anyway. So C2FO is collaborative cash flow optimization. Buyers set a target return they're looking for, suppliers set a unique early payment rate, and then our markets fill these orders for cash. The reason I tell you all of this is with our theme, the roles that we play, I thought to myself, what really is our role in DevOps and in engineering? And I kind of put this together, and I think it's to provide innovative, reliable, easy-to-use applications that help liberate working capital for the benefit of both the buyers and suppliers using C2FO. And I would like to underline that first part is the innovative, reliable, and easy to use. So that's kind of what our role is in the business. So how do we do that? I've only listed a few of the slides here, or a few of the technologies that we use here. But you can see we've got kind of a wide array of things that help make that happen. This is stuff that our operations team supports, that our developers build on, and that we manage. So with that, I kind of want to tell you about our journey to a multi-cloud architecture and some of the challenges that entailed, and hopefully you guys can take away something from this and implement it in your organization. So this was our general process as of Q4 2016. In the bottom left here, we have this thing called Frenzy, which was our automated deployment system. And deployments would go something like this. We would build Docker images for all of our repositories that we were going to deploy. We would then push those artifacts, being Docker images, to a Docker registry. And then for all of our servers, they would pull down those images. And then we would stop and start the blue units behind an Nginx server, and then stop and start the green units behind Nginx, taking care of the availability and uptime. And this was all in the Amazon side. So this is what a typical web tier of ours looked like. And down here, we were using Fleet, if anyone's familiar with that, to enable these units and stop and start them. So this is kind of a diagram of how we would promote things through each environment. So we have an FSS environment, which is our staging, and then a user acceptance test, where we allow our users, our external customers, to test if they wish, and then production. So this was me at the end of, or going into Q1 2017. I was a happy DevOps, We had automated deployments. We could deploy multiple times per day even. Hot fixes going out were really quick if we had to get them out. We were making deployments to our deployment tool, and we had further dreams, of implementing backout strategies if our deployment tool failed, updating our scheduler to run tasks more efficiently. We had a few small fires here and there, but nothing too big overall. And we were meeting our business's needs, most importantly. And I was starting to think, hey, we want DevOps. But Han Solo had other ideas, Great kid, don't get cocky. And so right around that time, we got some new business requirements. I don't know if any of you guys have been there before, maybe. So the first one was obviously move to a multi-cloud architecture. So the impetus behind this was we signed a new, very large client who was in direct competition with Amazon. So they didn't want any of their data stored or processed in AWS. So there was also a requirement to be able to scale globally in the future. We knew this was kind of coming down the pipeline, that we would maybe be expanded into Europe or other regions, and that we'd need to do that, so kind of plan with that going forward. And then this one, go live in about 5 to 6 months. This one was pretty intimidating for us, but since our new partner was very excited to partner with us, that was kind of our timeline that was set. And then, of course, as everyone here can probably relate, keep the lights on, right? It's just a utility, just keep it up. So this was kind of my internal face at that point. Yeah, like, okay. I've grown accustomed to the cloud, One's, we kind of got the reins on it. Maybe two's not so bad. It'll be interesting. So as the weeks go by, we find out there's more requirements. Oh yeah, we want to deploy approximately 3 new applications during this time, so yeah, that'd be great. And these were in no way related to our multi-cloud effort. Oh yeah, and then another one, as I mentioned, we used Fleet. We found out, mid to late Q1 that Fleet was going to be deprecated. So this tool that we use to schedule all of these Docker containers onto our host, it was going away. But as you can see here, they kind of left a little note that they recommended Kubernetes for all the clustering needs. The other big issue that we had with Fleet is that it was kind of very basic as far as scheduling. We had to kind of manage a lot of the advanced rolling deploys like I showed earlier, but it was a known quantity and it was very, very stable for us. So at this point, this is kind of my internal face thinking, okay, these things just keep stacking on top of each other. We only have 3 members on the DevOps team. We have to deploy and manage and are responsible for uptime of 2 clouds now in the next 5 to 6 months, Yeah, this was, I think someone took a picture of me there, actually. So we kind of sat down and we thought to ourselves, okay, we have to make a decision, right? So when we go multi-cloud, are we going to keep Fleet? It's going to be less work to deploy. Like I said, it's a known quantity. And it would allow us to kind of kick the can down the road, and we could save the problem for later of it eventually being deprecated in 2018. Or there's Kubernetes. We were fully Dockerized at this point already. So we were deploying, I would say probably 90% of our stuff with Docker. So we had that down pat. Kubernetes was getting more and more stable. Lots of desired features that we could take advantage of. In all honesty, we probably wouldn't have attempted Kubernetes on our short timeline if it wasn't for GKE, which is hosted Kubernetes in Google in their compute platform. So we thought to ourselves, hey, Docker and Kubernetes, so hot right now, I mean, if you go onto GitHub and you look at the repo, 55,000 commits, 27,000 stars, around 1,400 contributors. There was lots of buzz in all the forums and chat about it, so why not give it a try, right? So rolling into Q1 2017 towards the end, we started to get everything set up. We got VPNs between AWS and GCP. We got our VPN set up between corporate and GCP. We launched our first Kubernetes cluster around the end of March so we could begin building. We deployed some simple apps, like Rabbit, Mongo, just some other apps that we had, and we tried to see what we could do to break it, kind of testing to see how stable it was. Rolling into Q2, we got our automated deployments down in our Frenzy tool that we're telling you about. We made use of this tool called Helm, which is also managed under the Kubernetes project. And it basically allows you to create packages for your applications. We kind of have a complex microservices architecture, so this was a huge help of being able to kind of package this up for every single environment and expose the things that we needed to tweak. We also got another DevOps engineer, Chris, who was a huge help to us. We were really lacking instrumentation and monitoring, and he was a huge help in getting those things going. So we could kind of close our feedback loop, If you have instrumentation and monitoring, you can see when things break, what's broken, you can be alerted and then fix those and kind of go on your way. So we were also able to focus on more DevOps priorities, and he really just helped out in that aspect as well. So Q3, we got our UAT environment up, which allowed the client to test. And luckily we had our deadline pushed back a couple weeks. We would have been ready to go live just as early, but it really gave us just a little bit more time to solidify our process. We were able to spin up JMeter to do lots of load testing, and we also got prod up. So that was a pretty big accomplishment. So what does prod look like to us, right? Or what does our Kubernetes environment look like for that matter? So if you're familiar with Kubernetes, what a deployment and pod are, in each of our environments, we're running around 47 deployments just for our main application, which is a lot, and 110 pods. So if you actually look at how many containers we're running per environment, it's probably around 112 to 13 because we have a few pods that have multiple containers. So that's pretty impressive for us and just how fast we were able to get it up. We also run 3 separate clusters. Our FSS and UAT environment run on the non-prod cluster, and then production runs on our production cluster. The testing cluster is kind of for our DevOps team internally, so we can test actually doing Kubernetes upgrades to make sure they won't break anything. Allows us to test, will the app have downtime if we do a rolling deploy, or if we take nodes out without warning what's going to happen without impacting any of our other environments. So you can kind of see how many pods per node, which is roughly how many containers per node are running. So in my opinion, at least, we're getting pretty good density off of these. And we have auto-scaling turned on in our non-prod cluster, so we can kind of see what will happen when it does auto-scale. But for production, we limited that to a non-auto-scaling cluster, just so we don't have any surprises. And one of the biggest things is that we can spin up a whole new environment, everything included in only 10 minutes, which was a pretty big accomplishment for us. And really also helped to lower that feedback loop. So at the end of this, I had to ask myself why. Why were we successful? What made us, everything could have gone wrong, but why did we have any inkling of success? How are we able to double our cloud footprint and everything that's associated with it in just 6 months? I mean, and that's planning and implementation on both the application and infrastructure side. And it was kind of important so we would know how we could recreate this later, and also what could we improve on. And I think the 3 main categories are our use of open source software, our internal process, and our culture. So making use of open source software, on the application side, our engineers made use of Spring Cloud and Netflix open source software projects like Zool. And they did this so that they could implement an application gateway that could intelligently route and aggregate requests between our clouds for easy user experiences. Going back to our requirement that we had to host our data separately to meet business needs, they really met that challenge in flying colors. On the infrastructure side, we leveraged Kubernetes and Helm, like I mentioned earlier. I can't speak too much to the application side, but I'll tell you a little bit about the infrastructure side. So Kubernetes, what needs did it meet for us in our business? So because we got that bin packing, being able to schedule more containers per node, we really reduced the footprint and cost of our infrastructure. In AWS, we were manually scheduling these services onto boxes with Fleet, and certain boxes did very specific things, and you had to keep them up, and were responsible for them. With Kubernetes, we were able to kind of get away with that because we don't care where something's scheduled. In addition, it provided many complex features that we didn't have to write, which was a really big one, and furthermore that we don't have to maintain. They're maintained by a community. Things include intelligent rolling deploys. So early on, we had an issue where we had bad code go out. But because we had health checks on those, Kubernetes noticed that those new pods weren't passing health checks and didn't send any traffic to them and just kind of froze it, still leaving our old containers to serve traffic, which was pretty awesome for us. It kind of gave us a warm, fuzzy feeling that there was a system that was kind of protecting us and smart enough to do so. Namespace DNS was a huge one. I don't know if any of you guys have configuration problems, lots of configurations for different environments, but with namespace DNS, we were able to use short names in all of our configurations, and it basically isolates that DNS per namespace, which made our configuration really easy. For service discovery, Kubernetes uses label selectors, so you can really get kind of creative on how you want to mix and match which containers are exposed behind a VIP, basically. So that was pretty awesome, and it's very low configuration. Another benefit for us was no snowflakes. Like I said, we could schedule any container anywhere we wanted. We didn't have to worry about, is an OS update going to break a box, and are we going to lose, a snowflake? On the core OS side, we had multiple boxes, but we had to kind of, take care of those and make sure we do OS updates. Rebuilding wasn't as easy. On the Kubernetes side, we just spin up a new node with a brand new OS that's up to the latest patch version. It'll migrate load, and then we shut the old one down. There's really no concept of patching a particular node. It's also meant that we could scale up very quickly. So if you don't care where you run things and you need more capacity, you just add more capacity and you can scale up how many pods you're running in a deployment. So the main goal from this is it saves our business time and money in terms of operational energy. We didn't have to worry about things so much that we really didn't want to worry about. And then the declarative syntax. I think this is a huge one. It's kind of like when you go to a restaurant and you tell the waiter or waitress what you want. You don't tell them how to make it. In the same way, you tell Kubernetes what you want it to do. We didn't have to automate stuff. We didn't have to tell it, okay, I want you to stand up a new one and then migrate load and then back. You just tell it, I want this. And then we used Helm for our package management, which really got us release management. We could kind of see, okay, how many deploys were there in a certain environment? When was the last deploy? And like I said, with this packaging feature, it made it very easy. The TLDR behind all of this is that it'll save your business time and money by leveraging software that other people has written. You don't have to maintain it. So I also think that our process was a huge part of why we were successful. I would say we have around 90% of our deploys are automated, if not more. Day one that I joined, I did a deploy. And when Chris joined, he also did a deploy on his first day, which I think is really valuable to show people that you've got a fast-moving pipeline and you've got a robust automated process that you're not afraid to break, and it's something that you value. So we were also working on more blameless post-mortems. We did the first one that I've ever done while we had an outage, actually. We deployed UAT, and our customer was supposed to be testing it, and it was down. It's kind of a high-stress thing when you're supposed to be showing off, what you're capable of and what you're going to deliver, and it's not there. It would have been really easy for us to start, yelling and shouting and blaming people, but we did a really good job of saying what went wrong, and it actually turned out to be a communication problem that led to a configuration problem. We could now deploy faster than we could communicate what was actually going on in our organization. So I think that was really valuable, and I think it's something that we're working towards. Our processes are really flexible to change. I feel like maybe the bigger an organization gets, the harder it is to change stuff. But we kind of keep it. Nothing's off limits. If there's a process that's going to improve efficiency, we're all for it. And then this is something that I personally value. We have these all-hands meetings where we get everyone in engineering together for a forum. If there's something you don't like, you can speak up and have the floor. And it kind of it's like a synchronization mechanism, I think, for all of engineering. And then last is our culture. So we hire really good people. Every day I go to work, I'm learning something from someone else, and I hope they're learning something from me. We don't have any sacred cows, so to speak. Like I mentioned earlier, even if someone's really high up, an architect or something, you're welcome to challenge their stuff. And everyone realizes that it's just going to make a better project, you know, and a better product overall. I'll be honest, it's not all rainbows and butterflies. You know, people get heated. There's, you know, it's hard to get attached to our work. When we're working on things day in and day out, it's very hard not to get attached and view things as, you know, kind of like our children, you know. This is a big one. We trust our employees. We don't report our time each week. We have an unmanaged vacation policy, and we're given the freedom to innovate and make changes. Take calculated risk, if you will. Like this thing with Kubernetes, it could have, you know, fell on its face. And even earlier with Fleet, you know, it was being deprecated, you know. That left us in a tight spot. We had to come up with something new. It wasn't a long-term supported kind of product. But because our company trusts our employees, we're able to take those risks that are ultimately give us a better result and save us time and money. All right, so now I kind of want to go over the lessons learned from all of this and hopefully some takeaways that you guys can kind of implement in your process or just things to think about. So I think we could have collaborated more and tried to deploy. So early on when we got this news, we kind of split up, I feel like. So engineering kind of went their way and said, okay, what do we need to do to make the application work across multiple clouds? And then as I mentioned earlier, the DevOps team was kind of like, all right, we've got to get all this work done on the infrastructure side. And things kind of went by for a few months, and then we tried to do big bang, right? We kind of said, okay, let's run this stuff on here and see if it works. And it wasn't a success right away, no surprise. It took us a little while, but I mean, luckily we got it working. I think had we pushed that back and tried to do more testing, even if we knew it was going to be a failure, you know, even if we knew it wasn't going to work, just try it to see what was going on. I think that would have exposed an issue, which is not all software is created equal. You can't just expect to take software, stick it in a container, and expect it to work. I don't know if any of you guys have shared this experience, but it was one that, you know, we learned. While we were containerizing more of our software, we kind of had to adopt it even for it getting moved around and getting rescheduled, because before on the AWS side, it was fairly static. I think we'll see the best results from apps that follow the 12-factor pattern. It's kind of like a guidebook for, you know, how to write a containerized application that will work well in this kind of environment. If any of you guys have worked with Consul, we had some real frustrations that I think would have been exposed had we done what I mentioned earlier and tried this early on. I actually looked just the other day, and I think it was 3 days ago they merged a PR, which will fix our problem. But Consul, up until then, doesn't really run that great in Kubernetes. And we were kind of relying on it because our development team, it made things really easy for them. It was going to help them meet their business needs, but for operations, it was kind of frustrating. Kubernetes doesn't really care what IP you get, and it'll move you around a lot. You know, if a node drops, you'll get a new IP. Well, Consul doesn't really like that. It likes to talk on IPs. So, and it's kind of a consensus service if you think like etcd. And so this would go down for us a lot. And it was very frustrating, especially when we cluster this across the WAN. We'd have to go into the other console in AWS, and we'd have to reset this every single time. And this was a big frustration, that had we moved back earlier, we would have seen and we could maybe run it outside of Kubernetes. All right, this was a fun one. So use Kubernetes, they said. Yeah, it'll keep containers up. Yeah. So a quick story behind this is it was around 5:30, about a week before our go-live date. And the on-call got a bunch of alarms from the non-prod Kubernetes cluster. A little less than half of our nodes in the cluster were suddenly marked as not ready by Kubernetes. And some of them we couldn't even SSH into. After finally getting able to log into a node, we couldn't even use system control to see what was going on. We got system control failed to get properties. Activation of org.freedesktop.systemd1 timed out. Okay. Trying to reboot the node also failed with failed to open dev and init control. At this point, you're thinking, I'm screwed. What's wrong? Like, how do I fix this? But you quickly realize that's the wrong mentality. We further looked at top and we saw that nothing was running. Why was nothing running? Like, this was the lowest CPU utilization I've ever seen on a system, like as near to 0% as you can get. So as it turns out, we had a pod spec that was deployed, and we didn't limit our CPU or memory requirements. You know, Kubernetes should have prevented this with its QoS, but we think an killer happened, and it wiped everything out. So we ended up going into the Cloud Console and just hard resetting the box and quickly realizing that, oh yeah, I can just spin up more nodes or delete even the ones that I have to fix it. It's pretty great. So the lesson learned from that is if you're using Kubernetes, maybe turn on node auto repair in prod because it kind of notices this stuff and will fix it. And also set your resource limits on pods. But this leads me to my next point. Kubernetes is not a silver bullet. Like I mentioned before, what had actually happened was a cascading failure. So great, it'll orchestrate all my containers. And if one fails, it'll reschedule it. But if that one happens to be problematic, it'll actually cascade and take out most of your cluster. So there's still issues, is what I'm trying to say. We also had issues with inodes. It doesn't fix things like that. You'll have to configure more storage if you're going to be writing a lot of small files. Like I mentioned before, resource limits cause Docker crashes. We saw storage attachment issues where a pod wouldn't be able to schedule because we couldn't get a storage attachment to the VM. So the point I'm trying to make, though, with this is even though we had problems, it's kind of like Maslow's hierarchy of needs. We were working on higher problems. We weren't doing the same repetitive work over and over again. We were finding issues, fixing them, and then we really didn't see them too much after that. And I kind of want to wrap up with implementing DevOps processes are hard. Looking back, I could see so many things that we could change and that we could have implemented into our process to get faster feedback loops and a better process overall. But I think that's why they're called DevOps practices. You have to keep practicing them, keep being diligent to implement them until finally you get mastery of that and it becomes second nature in your organization. But it's well worth it. I mean, with this, if what I can give you is, those things that we implemented, we were able to go to a multi-cloud architecture in what I think is a very little amount of time and have fairly good success, and mainly people not hating each other or their jobs. So, and that's all I've got. Thank you. I think we had a few minutes for questions if anyone wants.
Anyone have questions?
No?
Going to Google, how did you transfer that knowledge from using AWS to Google API for transferring like Ec2 instances to something over at Google?
Can you repeat that, microphone?
Sure. When you were forced to go to Google, how was that transition? What was the learning curve like from Ec2 instances to doing something over at Google that you might not have had any experience with?
To be honest, it was pretty low. You actually there's a lot of comparable features. Like the metadata service that you get on an EC2 box is pretty similar. It's like a different route slightly, and you have to pass a little bit different header. But you get back a lot of the same information that can tell you, like what region you're in or what kind of instance type you're on. So it's pretty comparable there. With Kubernetes, though, and having that hosted Kubernetes, that's really the interface that we kind of programmed to, if you will. We had these declarative pod specs, and that's really all we had to worry about. Occasionally, we would still SSH into them and check stuff out. But there's actually a tool called kubectl where you can actually exec straight into a Docker container, and it handles like the transparent SSH for you. So you're not like SSHing into like a VM like we would on EC2 and then Docker execing. You can just use this tool and exec straight into it, and you're directly in the container. So a lot of the tooling was really good, and I would say the learning curve was pretty low.
Cool, thank you. One other question. Here we go.
Are you doing Kubernetes on AWS now as well, or just on Google Cloud Platform?
That's a great question. We're looking to move to Kubernetes on AWS. If anyone's actually set up Kubernetes before and managed it, it can kind of be a little bit of a bear. That's something that we want to get to, though, to make our deployment process consistent on both sides and kind of provide that unified experience to like our developers and internally. But we just need the time to do it. So.
Thank you.
Yep. Also,
Jonathan Stacks.
Also, shameless plug, we're hiring for a DevOps role, so if anyone wants to come talk to us out at the booth, just drop by. Thanks.
Thank you.